So to review these two exit ticket questions, this is a question you're going to see a number of times throughout the lesson itself, and in some of the things you're asked to do. So, and they commonly do ask this kind of question. Basically, you have, triangle ABD split into two smaller triangles, ABC and ACD. And they're giving you a list of six angles here, and they want you to distinguish which one is the largest or greatest in measure amongst them. There's no measurements given, and we really haven't learned how to take side measurements and find angle measurements, although there is a method of doing that. So we have to kind of logically determine how we're going to figure out which one of these six angles would be the greatest in measure. So first thing I do notice is that triangle ABC is isosceles, so whatever angles B and ACB are, or BCA as it's listed here, they're going to have the same measurement. So if I know one angle is going to be more than another angle, one of these two angles, then I know it's going to be more than the second of the two angles too. I know that angle BCA is acute because triangle ABC can only have one right angle or obtuse angle. So with the fact that the two biggest angles are congruent, they must be acute. And I know that the biggest angles because of the fact that the sides that they're opposite 6-inch sides, while BAC, which is what A is smaller than them. So I know BAC is smaller than these two, and these two are both acute. I know that angle ACD is obtuse because it is a linear pair with BCA. I also know that angle ACD is greater than angle B because it's congruent with ACB. So since those two angles are congruent, then since ACD is greater than one, it's greater than the other. Angle ACD also happens to be the biggest angle I have in the triangle ACD. It's opposite an 8-inch side, while the other two angles in that triangle are opposite a 6-inch and a 5-inch side. That means that DAC, ACD, they're acute angles. So all the angles that are listed here, angle BAC, angle B, angle D, angle BCA, and angle DAC, are all acute angles, while angle ACD is the only one that I have verified is obtuse. And because of that, it is the one with the greatest measurement. Now, I don't know what that measurement is. We haven't gotten that far yet. There are methods, and that's more of a trigonometry concept, but there it is. The second thing you were asked is whether the triangle shown below can be constructed, and to explain your answer. And you have to remember, these things are not drawn to scale. It looks like we have a triangle there, but as it's laid out, you can see very carefully that the triangle has the largest angle, which in this case would be 66 degrees, opposite, it's not opposite the longest side. The longest side is 9 inches, and the 60-degree angle is opposite that. Therefore, we would never, can we get triangles with these three angles and perhaps these three sides involved? Maybe, but not laid out the way it is. If the 9-inch side and the 8.5-inch side were switched positions, then the triangle might be able to be constructed. The rest of it would come down to other formulas as such that we have not learned about yet that would determine if those would be the actual lengths. But, we're looking for possibility only at this point. That would be possible. This, impossible, because I can't have the largest angle be opposite anything but the longest side. And that's the end of that explanation. If you have any further questions, please feel free to contact me or your geometry teacher. Until the next time, have a good day, everyone. Bye.